Hi there, in this video we're going to be solving a variety of limit problems. Now the first one I think I want to demonstrate is going to be the relatively simplest one. As x approaches, let's say 2, for the function x cubed, subtract 8 over x subtract 2. What is the limit as x approaches 2 for this function? Well, we can see if we put a 2 in here, there's going to be a 0 in the denominator, and we can't have that. So what I'm going to do here is I'm going to factor the numerator using the cube law, which would, if I were to do this, would become x subtract 2. Then you square the first term, so it's going to be x squared. Then you would do the opposite of the sign here, so that's a negative. We're going to do a positive here, positive. Then we multiply this one to the next, so it's going to be positive 2x, and then it's always positive at the end. It's going to be positive, then the last little segment here squared. So negative 2 squared is going to be a 4. So that's what I'm going to have as the numerator. It's going to be over x subtract 2, and we can already see that it's going to be canceling out with the top one there, leaving us with just a. Now we can see that if we were to take the limit as x approaches 2, we would have a 4 right there, so it's going to be 4, put a 2 in here, it's going to be another 4, and then another 4 right here, leaving us with an end answer of 12. And that's the end result, or the answer to this particular limit problem. Let's call this A. Okay, let's go ahead and start another problem. The next one we'll call question B. Let's have it be, no pun intended, it's going to be the limit as x approaches 0 for the function, let's say 2 add x squared, all of this being square rooted, subtract square root of 2, subtract x squared, all within the square root there. And all of this is going to be over, let's just say x squared. So how would we solve this? Well, I'm going to be using the difference of squares. We can see that this is like one component of it. So if I did something like this, the square root of, let's say 2 add x squared, but instead of, remember, we have to change the signs. So negative there, you're going to have a positive over here, then square root the other term, 2 subtract x squared. And if you do this, since you're doing it to the top, you need to do it to the bottom. So it's going to be. And now we can see that if we were to multiply the numerator across with its other factor, it's going to get rid of all of these square root signs, and we're just going to be left with 2 add x squared subtract 2 subtract x squared as the numerator. At the bottom, we're going to be having all of this. Okay, well, simplifying the numerator a bit, we can see the positive x squared and the negative 1 are going to be canceling out. Oh, well, actually, I forgot that this should have a bracket right there. Well, we can see we have a negative 2 here, which is going to cancel out with the positive 2, so let's get rid of those two. And we'll put that negative, it's going to make this x squared over here positive. Putting them across, it's going to give me just a 2x squared on top, because they're going to be added together. So we have 2x squared. And we can see the x squareds are going to cancel out from the top and from the bottom. So we get rid of those, and now we're left with this term here. And we can see, if we take the limit now, as x approaches 0, putting a 0 in for all the x's, this is just going to be a 0, so it's going to be square root 2. Square root 2 add square root 2. And if we put a 0 here, it's going to be another square root 2 again. Now we can see that I made a little mistake here. I don't know why I put an extra 2. Let's just erase that. It's just going to be the same as the top and the bottom. So, since those are cancelled, let me just rewrite it so it's a bit more visible. Now we're just going to be having a square root 2 add another square root 2 at the bottom. And if we were to add those, we would just have 2 over then 2 square root 2. The 2's cancel out, and we're left with 1 over square root 2 as our final answer. So that is the limit as x approaches 0 for this other function. So let's go ahead and solve another problem. In this problem, let's use as x approaches infinity this time. So let's do limit. What is the limit as x approaches positive infinity for the function 3x squared subtract 5x squared add 7 all over, let's say 8 add 2x subtract 5x cubed. Okay, so to do this one, to solve any sort of limit at infinity, the whole goal here is to factor out the x's. So what I'm going to do here is look at what is the highest x value I can factor out, because we want to get rid of the x's, mind you. And we can see we have x to the cubed, or x to the third. So I'm going to be factoring out that. So as the numerator, it's going to have x to the third, 3, subtract, and I'm just going to do 5x squared divided by x to the cubed, because if we were to multiply that across, it would still be 5x squared. So it is kind of factoring it out. Then we do positive, and we'd have 7 over x cubed, and now that's all going to be over. Then let's also factor out x cubed from the bottom, so x cubed. Then we're going to have 8 over x cubed. Add 2x over x cubed. Subtract 5x cubed over x cubed. And if we were to do that, if we're just to factor it out, it's just going to leave us with a 5 there, so negative 5. Now that we've done that, we can see the x cubes now cancel out. And any number, because we're going to an infinity number, it has no end, and it's going to be more positive, it will be positive. There's the rule we're going to be using is whenever you have a number like this, say this thing right here, the x squared over the x cubed is going to cancel out just to have an x to the 1 at the bottom. So it's going to be 5 over x. And whenever we have that situation and the limit is as x approaches some infinity, either negative or positive, in this case positive, it's going to be 0. So these two values here, this 7 over x squared or cubed, is going to be a 0 as well. Meaning at the end of the day, the numerator is just going to be a 3, because it's doing 3 subtract some number over x as x is approaching infinity, and we just say that's going to become 0. So it's going to be 0 and 0. So the numerator is just a 3. At the bottom, we're using the same rule, and this number right here is going to be a 0 as well with this one, and we just have a negative 5. So we put a 5 in here, and it's negative. And this is our final answer. This is what x is approaching in this function, or this is what the y value is approaching, I should say, as x is approaching positive infinity. And let's do one more question. Alright, question D. This one I'll use some trigonometry, I guess. So, what is the limit as x approaches 0 for, let's use the function 1 subtract cosine x over x squared. So how do we solve this? Well, we have to use the trigonometry laws, actually, because notice we put a 0 in here, it's going to be undefined because we have a 0 in the denominator. If we were to use the difference of squares, because there is no trig identity exactly like this, but if we had, for instance, 1 subtract cosine x squared, then if we had that sort of thing, then we could be in business. Now, if we were to do that, it would basically be, or it would be 1, but add cosine x. We're going to be multiplying the top and bottom by this. And if we were to multiply this across, we'd have 1 over here, then we'd have, let's say, negative that, and then we would have eventually positive that. So it would cancel out the middle term cosine here. But when it multiplies to the last term, we're going to be left with 1 subtract cosine then squared x. And that is actually something we can use. So let's put everything else down here. Alright, so this here is also it's a trigonometry law. It's equivalent to putting just a sine squared x, and that's actually using the Pythagorean, sorry, I keep pronouncing that wrong, Pythagorean theorem, which is basically a squared plus b squared equals c squared, but in terms of trigonometry. Anyways, all you need to know is it's equivalent to this, sine squared x, and at the bottom we're left with this term right here. Now I'm just going to erase some of this portion right here so I can give myself a bit more room. And we have to recognize here that, you can actually cancel out a lot of stuff here using some laws, using, I believe, the hospital law. Basically, if you were to do, you have to recognize that it's equivalent to putting something like this. Sine x over x multiply sine x over x. Because mind you, that would give you sine x or sine squared x over x squared, so it's still equivalent. But you also have to multiply by 1 over then this term right here, which will just be 1 add cosine x. So it's still equivalent to that, but we're working with this over here. So now I can just erase this so I give myself some room. whenever you have sine of some number over the same number, it's going to be equivalent to 1, which means both of these terms are 1. 1 multiply 1, which means our ending term is going to be just 1 over 1 add cosine x. And now if we were to take the limit of this as x approaches 0, so the limit as x approaches 0, put a 0 in for cosine, you're going to be getting just a 1. So it'd be 1 add 1 at the bottom, which means in the end, your answer is going to be 1 half. And that is indeed the final answer for this question. Hope you enjoyed, and I do hope you're having a fantastic day.